Hello everybody, welcome back for section 2. Today's topic is about chemical properties, and then we're going to talk about physical changes as well as chemical changes. So the first task that you have is to open the notes and click here. It's a very short textbook reading with a little video about chemical properties. Well, the video itself is chemical property in action. So there's an explosion that takes place. But a chemical property is one that can only be observed when the substance changes into a brand new substance with different properties that it had before. For example, flammability is the main one, and then the other main one is reactivity with acid, with water, or with oxygen. You could divide these into three separate categories because it is possible for something to react with water but not with oxygen. It's possible for something to react with all three. It's possible for something to react with just acids. So think about that as you're trying to decide if something is reactive or not. But the point is, you can't observe these properties unless the substance undergoes a complete change into a brand new substance. So once you burn a piece of paper, you are no longer left with something you can write on. You are left with a pile of ash. You're left with maybe the smoke. You're left with the heat was there and now it's being dissipated into the air around you. So you have a completely brand new substance after something burns or something reacts, and it has brand new properties. So that's how you know you're dealing with a chemical property and not a physical one. Okay, so we also have an iron chain link or chain right here. It has been rusted, so iron does react with oxygen. And we have evidence of that all over if you just take a look outside. Okay? Moving on. So a physical change, so earlier this week we talked about physical properties. A physical change will affect one or more physical properties of a substance, but the substance itself remains the same. The easiest way to demonstrate this is to tear a piece of paper. It's still paper. I can still write on each piece. The only things I've changed are the shape and the size, right? The edges might look a little different, but it's the same substance overall. Can I undo that? Not perfectly. I can't really undo it, but again, the substance is the exact same. I have some other examples here for you. Cutting your hair, it's still hair. You've only changed the length. And the length would be a physical property in that case. Sugar dissolves in water, and you can actually reverse that process. It's still sugar. It's the same thing. If something melts or if something boils, you can also undo that. It might not look exactly the same, so the chocolate may not return to this exact shape. However, it's still the same substance. Okay? So let me go back, I guess. So if the answer if the answer to this question, is it still fill in the blank? Is it still paper? Is it still hair? Is it still chocolate? If the answer to that question is yes, then you have a physical change you're talking about. Next, we are talking about chemical changes. And this occurs when one or more substances are changed into entirely new substances with different properties. These are very difficult to undo. I'm not saying they're impossible to undo, but some are, right? So for example, can you uncook an egg? No. Okay. Once you burn paper, you might be able to salvage this piece in here, but you're not going to bring that whole piece of paper back and undo that process. Once milk goes sour, you can't undo that. This is actually a cool chemical reaction. You mix two clear liquids and you get a yellow solid. So the fact that we have a brand new color that came out of nowhere and we went from a liquid to a solid without actually changing the temperature is pretty amazing. You can undo this though. You just need a chemical process to do so. So here are some examples. The clues that a chemical reaction has taken place: you have a new texture. So with an egg, you definitely have a new texture, and your color has gone from clear to and transparent to opaque. You cannot see through it. A new color, light, or sound. Here we have a new color. We have light here. A temperature change. So this could go either way. Living in Alaska, I'm sure you've probably had those hot, I think they're called hot hands, where you break the package a little bit, and then all of a sudden it gets warm. You can put that little, it's like a little mini portable heater. You can put it in your shoe or your glove or whatever to stay warm. We also have ice packs that do the same thing. You break the chemical, there's a little container inside, you break, and the chemicals mix, and it becomes an instant ice pack for you. So, I know maybe not everybody has heard of that, but they do exist. And then lastly, my favorite sign, bubbles, fizz, or foam. If that happens, that likely a gas has been produced, which means that that wasn't there before, and you now have a new substance. So these are your clues. You do want to write those down. Again, I highly recommend going back and reading about chemical properties. Other than that, that's it for this video.